So today what I want to talk to you guys about is difference quotients, equations of tangent lines, and also equations of normal lines, all right? So we got to start with what we talked about yesterday, and that's secant line, or average rate of change, all right? And so I want to start right here with this point. I'm going to draw this in, and I'm going to call this point, it's going to have x coordinate a, all right? And let's call this function y equals f of x. So if this is f of x and this x coordinate is a, then this point would have to be a comma f of a. All right, now what I want to do next is I want to go to the right of this. I need another point, right? So I'm going to go to the right a distance of h. Now you're going to understand a little bit why I'm calling it h and not go, wait, Mr. Mitchell, that's 1, 2, 3, that's 3. No, it's h, okay? So right here, I'm going to go straight down, and then this would be a plus h, which would make the coordinates right here of this point right here, this one would be a plus h comma f of a plus h. And now, because I've created the second point and we have 2 points on this curve, we can find the slope between them, right? So that's what I'm going to do next is I'm going to use my handy dandy ruler, like handy dandy notebook, like Steve on Blue's Clues. Some of you guys remember that. All right. Okay. So the slope here between these 2 points, all right, would be, and this is called the slope of the secant line. That would equal f of, and we usually take the point, we start with the point on the right. So this is the left point, this is the right point. We're going to start with the one on the right. So f of a plus h minus f of a all over a plus h minus that a right there. Okay, so that cleans up, and that becomes f of a plus h minus f of a over h. And that is the secant slope, or we also call it average rate of change on the interval a comma a plus h, a plus h. And that's also called AROC. All right, so that's nice. Okay, that's slope between 2 points. All right, we've been doing that since, 8th grade, freshman year, so on. Okay, all right. So what happens, how can we find the slope at exactly 1 point? Like, this all hinges on having 2 points, right? How do you get the slope at 1 point? You need to subtract, right? You need to do a difference, right? And this is called a difference quotient, because we're subtracting the y coordinates over, and it's a quotient because you're dividing. So we're subtracting the y coordinates, and then we're down here, we're subtracting the 2 x coordinates. Some people put parentheses around this just to show that's one x coordinate and then that's the other x coordinate. All right, so I'm going to show you next how we go about getting the slope at 1 point, right? Just 1 point. All right. So I kind of drew part of this already, just so you wouldn't have to sit here and watch me draw it again, okay? So this point right here is, again, and I should say, this is y equals f of x. And this point right here is a comma f of a. And this point right here is a plus h comma f of a plus h. And the big deal here is I want to find the slope right here at this 1 point, at this point. So I need a second point, right? So to get the second point, I'm going to go h units to the right. And that, if I go h units to the right, that's going to cause a new x coordinate. And then I have 2 points on this curve, all right? So how do you go about getting it so it's just slope at that 1 point, right? So I like to call this the anchor point. There's better words for it. There are more technical. It's also called the tangent point, okay? But we're gonna bring this point right here. The way to do it is this h right here. That's why the h is important and not saying, oh, 3. This h is gonna change on us. And what we're gonna do is we're gonna shrink this. So if I make this get smaller and smaller and smaller, right where this point is, it's gonna move in this way, right? And because that's moving in here, that's gonna cause this point that's up here on the curve to also move in this way, right? Move to the left, which is gonna cause it to come down. In this particular function, it's gonna go down and left, right? But it's coming down, coming down, coming down, coming down. And as we make this go more and more and more and more and more, right? It's getting closer and closer until right at the moment h becomes 0, we have 2 points on top of each other, right? And that's the idea behind it. So I'm going to draw my line, my tangent, well, not tangent line yet, okay? It's a secant line. So if I bring that point in, this is going to start to tilt, right? This red line is going to start to tilt more and more kind of this way, right? It's going to move this way. All right. So how the heck do you get h to shrink? Like how do you make it becomes or approach 0? So think about that, right? For a second. How do you make h approach 0? And there's a reason I taught you last unit before this. What is it? It's limits, all right? So if we want to find the tangent slope, at x equals a, this is one of 3 different ways that I'm aware of, okay? One of 3 different ways that we can find it, all right? So this is what we could do. Okay, so we have right now we have 2 points, right? Right now we have 2 points. And it would be f of a plus h minus f of a over a plus h minus a, which is really just h, right? Now, how do I make this become 1 point? And it requires us, because right now we have 2 points, what it requires us to do is to shrink this h. And so what we do is we write lim in front of this. I should have told you if you're writing notes, leave yourself some space right here, okay? Too late. So lim as h approaches 0. That's all you do. And that right there causes this point to move in, get closer and closer and closer and closer and closer. And we're looking at the value of this as h getting closer and closer. And what happens is if this comes out to be a number value, then that would be the slope at x equals a. All right? And that's one way of doing it, okay? This is called the right difference quotient because we're picking a point to the right of the one we're trying to find, right? So that's why we're going right. Okay, so we're trying to find the slope at point A. We are going to go to the right by adding h to that a value to get our second point. Conceptually, if you understand that, that's going to make sense of what we're doing. Okay. All right. Let's do two. Well, let's do another way. We're going to do two other ways. All right. All right. Another way of doing this is to pick a point like right here, and we're going to find the tangent at that one. Okay. So we're going to call this A. And instead of going to the right, I'm going to go to the left. Okay, so I'm going to go to right here. And then right here would be my second point. And the way we get this is we take A minus H. All right, so then that makes this point right here, and I should have said this is y equals f of x still, all right? And then this is gonna be a comma f of a. And this point right here is gonna be a minus h comma f of a minus h. All right. I should have said this in the one before. This h right here, sometimes some books and some professors call it delta x. A lot of people like to use H because it's one symbol instead of having to write two symbols, and it's just a little bit easier to work with H than it is delta X. Okay, because sometimes we're gonna have to square this, and so it's kind of hard to square delta X, but it's easy to square H. That's just H squared. Okay, not difficult. It's just the symbols make it a little more cumbersome. All right. So what we're gonna do this time, all right, if we want to find the slope at right here, right, we need 2 points, and there's our 2 points, okay? And so our tangent slope, for the sake of brevity, I'm not going to write at x equals a, okay? Okay, so the tangent slope would be this, all right? So we're going to do f of a, because that's the one on the right, minus f of a minus h, and leave a little bit of space here. So this would be f of a minus f of a minus h, all over. Now this time I need to write a minus, and I need to subtract all of that. And the only way to subtract all of it is to put it in parentheses. And all right, so what we're gonna do is, again, we're gonna make this h shrink. We're gonna make it go to 0. And what is that gonna do? That's gonna cause this point right here, if we make h go to 0, this right here is gonna slide over, which is gonna cause this point to move along the curve and approach this value at x equals a along the curve, okay? So we're gonna make limit as h approaches 0. So that's equal to the limit, I'm gonna clean this up a little bit. Limit as h approaches 0 of f of a minus f of a minus h over a minus a plus h. Well, that becomes the limit as h approaches 0 of f of a minus f of a minus h over h. And this is an alternative way, okay, of getting the slope of the tangent at x equals a. All right. Same idea. We're just picking a point to the left of it, right, instead of to the right of it. That's all the difference is. Okay. All right. And there's going to be one more way of doing this, and it's called the symmetric difference quotient. And we'll do that one next. So I drew part of this to start to save time. Here's where we're going to find the tangent slope at A. And what we're going to do with this one, because it's symmetry, right? It's symmetrical, okay? We're going to go symmetrically about A, right? So we're going to go to the right, H, and we're also going to go to the left, H. That would make this point right here a plus h, comma, f of a plus h. And then this point right here would be a minus h, comma, f of a minus h. All right, and we're going to connect. There's our 2 points. That's not going to be the anchor one this time. And this is just an alternative way of doing it. So there's my secant line, right? Because it's 2 points. Secant lines are 2 points. And so what we're going to do now is, and I should have written this. This is a plus h, and this is a minus h. And so what happens now if we shrink this h? Well, both these are going to slide in this way, right? Which is going to cause these to slide in, which is going to cause these points to slide in. So these 2 points are going to come along the curve and come in, and horizontally they'll be the same distance from this point right here all the time. Okay, and you shrink them down, and then these 2 points, and we wind up getting the slope of the tangent at x equals a. But again, it takes a limit, right? Because we've got to go from 2 points to 1 point, and the only way to do that is shrink the h. That's why earlier I didn't say 3, okay? And say, oh, a plus 3 and a minus 3. No, because we need to get that to shrink, right? And if we leave it at 3, that means it's always 3. All right. So once again, tangent slope here. So tangent slope on this one, it's a little bit different, okay? We're going to take the limit as h approaches 0, because we need to shrink the h to get to the 1 point. And it'd be f of a plus h minus f of a minus h over a plus h minus a minus h. Cleaning this up, that becomes the limit as h approaches 0 of f of a plus h minus f of a minus h over a plus h minus a plus another h, right? And so the a's cancel, but the h's actually add up to become 2h. So this one becomes the limit as h approaches 0 of f of a plus h minus f of a minus h all over 2h. And that's the symmetric difference quotient, okay? So the idea here, okay, is we have an anchor point and we go to the right and bring that point in with a limit, okay? So if we go to the right, that's a right difference quotient, and then we bring it in, we shrink it, so that's the limit part of it. We could also go to the left, right, and bring that point in, okay? That'd be a left difference quotient because we're picking a point on the left and bringing it in. Or we go points on either side of where we want to find it and bring them both in. Hopefully my fingers are doing a little dance here for you guys so you understand, okay? You guys are like, Mr. Mitchell, you're so weird. It's okay. If it makes you learn, I don't care. I'll do anything. I'll stand on my head. All right. I'll stop now. I think I just embarrassed myself. All right. All right, let's go to the next one. All right, so now we're going to use it, okay? So I want to know, here's the function f of x equals x squared. I'm going to want to do a really simple function, all right? And I want to find the slope right here at one point. Okay, so that would be my a. In this case, it's exactly 3, all right? And so what I want to do is I want to go h units to the right, and then that would put me up here at this point. Okay, and because I know I went h units to the right, this x coordinate is 3 plus h. I know it looks like it's at 5. It's not. It's at 3 plus h. Okay, and so this coordinates of this point right here would be 3 plus h comma f of 3 plus h. So I should say this, I don't want you to memorize these difference quotients. I want you to understand them. And there's a difference. I don't want you to memorize them. I just want you to understand it because then it leads to other things, all right? You understanding it better, all right? If you understand, you're taking a point and you got another point and you got to make that other point by going to the right or to the left or both sides, okay? That's how you get your 2 points. Okay, we're going to shrink this h, which means this point is going to move along here. And as h gets closer and closer to 0, as h is exactly 0, this point gets right on top of that. Okay? All right, so here we go. We're going to take the limit as h approaches 0. That's going to shrink it. And then this is going to be f of 3 plus h minus f of 3 over 3 plus h minus 3, which would just be h. Okay, so now this becomes the limit as h approaches 0, and we're going to put 3 plus h into the squaring function, right? So this becomes 3 plus h squared minus 3 squared, because it says put 3 in, all over h. Now I'm going to need to square this, all right? Please, 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 don't say 9 plus h squared. That's not correct, right? 3 plus h times 3 plus h it makes a square. That's a perfect square. So we can do an area model where 2 of the sides are the same length, right? 3 plus h. 3 plus h. That makes 9, 3h, 3h, and h squared. So this becomes, when you square this out, it becomes h squared plus 6h plus 9. So this is equal to the limit as h approaches 0 of h squared plus 6h plus 9 minus 3 squared, which is 9, all over h. So then that is equal to the limit as h approaches 0 of h squared plus 6h. This 9 minus 9, they cancel each other out over h. So from here, okay, so I should have said this earlier. Right here, we always want to try to do direct substitution, but look what happens when we try to do direct substitution with h being 0. That makes 3 plus 0, this would be 3, and that'd be 3 squared, this would be 9, minus, and then this would be 9, so we get a 0 on top, and then we get a 0 right here too, so we're getting 0 over 0. Not going to work, right? Even here, if we try to put 0 in, 0 squared plus 6 times 0, this is 0 and this is 0. So we're getting 0 over 0, all right? That's going to happen every single time on these difference quotients. You're going to get 0 over 0 every single time, okay? All right, so what can we do? There's a couple things. We're still going to need to write the limit as h approaches 0. Okay, so one option is this came from adding two fractions with a common denominator of h. So you could rewrite this as h squared over h plus 6h over h, and then you could cancel some h's, okay? Or, and this is the way I'm going to do it, there's a common factor of h in these two. So I'm going to factor it and h out, and then times h plus 6 over h. And what happens here? Right? Canceling, right? That's a sound effect for canceling, all right? Remember that? Okay, and so we are left with the limit as h approaches 0 of h plus 6. And now if I try to put 0 in for h, I can, because I'll have 0 plus 6, and so that's equal to 6. So basically what this is saying is the slope at that one point right there is 6. All right, so I'm gonna try to draw it. So I'm gonna try to come in and draw it so it's just tangent at that point. So I'm gonna try to get it right about there. Okay, and that's just kind of an estimate of it. All right, now that I'm not gonna check it, all right, see if I drew it right, but that would be touching like right there at that one point. Now this point is important. This is called the point of tangency. Where that tangent line touches the curve at that one point, that's always called the point of tangency. All right, so the next part of this, and I'm going to zoom out a little bit because I need this, I need more. I'm going to slide it up, is we want to write the equation of the tangent line at this point. So at the point of tangency, what is the equation of it? We have the slope, okay, but we need to write the equation of it. Well, to write the equation of a line, you need the slope, we got it, and we need a point. We got it. So we have it, right? And remember from last year, this is called point slope form, all right? So we know m tan is equal to 6. That's from right here. That's what we've just figured out. And we also know the point is 3, 9. So we could write this as y is equal to, now a basic line is y equals 6x, right? And the y equals 6x would go through the point 0, 0, would go through the origin. But we needed to get it to go through the point 39. So I need to shift it to the right 3 and also up 9. So that makes this 6, because of the slope, times x minus 3. Okay, that shifts the line to the right 3, but it doesn't shift it up to go through 9. So we add 9. Remember transformations? That will do it for us, okay? That's point slope form. That's called the point slope form of a line. And to be honest with you, that's where I would write. If I say write the equation of a line, I would write it like that and I would walk away, okay? Lately, I've been seeing this on the AP exam where they modify this a little bit, okay? And I know why they do it. It's some math that I never had a chance to teach you guys. But what happens is you move this 9 over. So this is just, I would call this an alternative form of point slope form, is you move the 9 over. and it becomes y minus 9 is equal to 6 times x minus 3. And I would just say this is an alternative form of point slope form. All right. And there's still one more way, and that is to distribute the 6. And we would have y is equal to 6x minus 18 plus the 9, which would give you y is equal to 6x minus 9. Okay, now the beauty of this form, let me slide it up a little bit. The beauty of this form is you can look at it and go, oh, that's the slope. All right, well, same way with these, you can look at it and go, oh, that's the slope. But you can tell here what the y-intercept is, and it's -9. And you can't tell from either of these that the y-intercept was -9. I know there's a -9 here, but that's not the y-intercept, so please don't think that, okay? All right? Okay, so this is called slope-intercept form. And the reason it's called that is because you can look at it and go, oh, that number's the slope, and that number's the y-intercept. All right? Again, if I ask you to find the equation from the tangent line, I would just write it like this right here, like this one. Okay? It's quick and easy. Let's do another problem now. So this time I've given you, it's really the same problem, but with a different function and a different x value. But I'm asking you to find the slope of the curve at x equals 4. Now notice something, okay? So we've got to kind of infer this. What does it mean to find the slope of the curve at x equals 4? That means at one point. So what this means, slope of the curve, means tangent slope. Okay, so and then I want to write the equation of it, okay? So where do we want to find it? We want to find it at x equals 4, which means that's one point, but I need a second point to write the slope. So to get that second point, I'm going to go to the right. I'm going to get that other point by taking the 4 and adding h to it. Okay, so we're going to find the tangent slope. That's the first thing we're going to do. Okay, so to find the tangent slope, that requires us to take a limit. So the limit as h approaches 0, not because we've memorized it, but because we understand we got to make that h go to 0, right? And make it go from 2 points to 1 point. And that is what's going to cause it to go from 2 points to 1 point. So this is going to be f of 4 plus h minus f of 4 over 4 plus h minus 4, which would just be h. Okay, so now our function, it doesn't really matter what the function is, but this specific function says it's the reciprocal function. We're gonna take 1 over whatever our input is. So in this case, our input is 4 plus h. So this becomes the limit as h approaches 0 of 1 over 4 plus h minus, and this says put 4 in, so that'd be 1/4 all over h. So let's try to plug 0 in, right? You try to plug 0 in and you get 1/4 minus 1/4. That creates a 0 in the numerator, and we're plugging 0 in for h here. So this is going to cause 0 over 0. Okay, so we can't do it, right? That's going to cause a hole. It's undefined. Well, what can we do? Well, we can algebraically fix this. Okay, whenever you get 0 over 0, you're going to be able to fix it. So what we're going to do is, the way we're going to fix this is, you should notice, and this is why I taught you this last year, hey, that's a complex fraction. So how do you get rid of a complex fraction? You get rid of these two denominators, or the denominators that are causing it to be a complex fraction, which are these two. So I'm going to need to multiply by 4 and also 4 plus h. Okay, so this becomes the limit as h approaches 0. And okay, so this is a difference of two things. So I'm going to need to distribute this with each of them. So when I take this and multiply it by 1 over 4 plus h, my 4 plus h's are going to be canceled, and I'd be left with 1 times 4, which is 4. Minus, that's that minus right there. When I multiply this times 1 over 4, my 4's are going to cancel, and I'm going to be left with 4 plus h, but I need to subtract the 4 plus h. So if I write it like this, I'm dead on wrong. Dead, totally wrong. Totally wrong. I need to put parentheses around it because I need to subtract the whole thing. Over, and then this would become h times 4 plus h because nothing cancels on that one. You could also write this as 4h if you wanted to. No problem with that. All right. So we're going to need to distribute this negative because if I try to, okay, let's try plugging 0 in again, right? So what happens here is this becomes 0. And so this is 4 and we have 4 minus 4. So we still have 0 on top. Here, if h was 0, this is 0 and I'm multiplying by it. So the whole thing in the denominator would be 0. So we got 0 over 0 still, right? Let's see where we can go with this. So we take the limit as h approaches 0 of 4 minus h over, and I'm going to write it now, 4h times 4 plus h. And then 4 minus 4, that cancels. So you're left with the limit as h approaches 0 of negative h over 4h times 4 plus h. And do you see it? Do you see it? Right? The h's. That's what's causing this to be 0 over 0 is those two h's right there, okay? Which are kind of because of what has been done to them, you don't see them like that right up here, right? So we had to do all this work, right, to get it down to see the h over h. Okay, so this cancels, and now we're left with the limit as h approaches 0 of negative 1 on top over 4 times 4 plus h. Now, can we put 0 in for h? You betcha, right? So we put 0 in and we go 4 plus 0, that'd be 4, times 4 here, that's 16, right? And we have a negative 1 on top. So this becomes negative 1/16. And that's my slope of my tangent line at x equals 4. Okay, so that line that only touches at x equals 4 at one point, the slope would be negative 1/16 if it's touching there at x equals 4. All right, so now we need to write the equation of the tangent line, right? But to find the equation of the tangent line, I need the point of tangency. So we need to find point of tangency. And we're finding the slope at 4, so that's the x-coordinate of the point of tangency. And all I need to do is put that into the function. So f of 4, and that'd be 1/4. So my point of tangency is 4, 1/4. So the equation of the tangent line would be y equals my slope, which is negative 1/16, times x minus 4, because I need to go through 4, so I need to move it to the right 4, and then I need to move it up to 1/4, so plus 1/4. And I would stop right there, okay? That's a perfectly great answer for me. Now, there's another way, though, you could see it. We could move this 1/4 over to the other side, and it would look like this. Y minus 1/4 is equal to negative 1/16 times x minus 4. And that's just the alternative point slope form. All right, I have one more thing to talk about, all right, and that's called the normal line. And then I'm going to show you something on the graphing calculator. Okay, so the next thing I want to talk about is normal line. Now, some of you who took physics last year, and I'm not sure if Mr. Jett got to this or not, but you may have heard the term normal before, because he probably talked about a force, and then he talked about a force that's working perpendicular to that force, and that force is called the normal force. So a normal force is perpendicular, okay? And that's basically what normal means, is perpendicular. Okay. All right. So let me write the definition of this. Okay. And so what I want to say is it's a normal line is a line perpendicular to the tangent line and it's not just anywhere, it has to happen at the point of tangency. which is that point where you found the tangent line slope, okay? Now, what does perpendicular mean? Perpendicular means right angles. So if you see a line that looks like this, let's say that's the tangent line, and you come in perpendicular to it, okay? This would be called, this would, if this was the tangent line, and right here was the, right where they're intersecting, that's the point of tangency, then this would be called the normal line. Okay, so I should slide that down a little bit. Okay, so there's something about slopes and perpendicular. And I should say this, the symbol for perpendicular is an upside down T. All right, so M tan, let's say the tangent slope is 3/7. Okay, almost always, all right, if you know the slope of the tangent, which is 3/7, you can come up with the slope of the normal line, because if they're perpendicular, perpendicular lines always have this characteristic, okay? Their slopes, we say, are opposite, which means one's positive, one's negative, and also reciprocal. So if we know one of them, we have to look at the opposite sign of it and take the reciprocal of it, which means flip it. So M perpendicular, okay, that'd be the normal slope, okay? This one's positive, that means this one's gonna have to be negative. This one's 3/7, this one has to be the reciprocal of it. So we have to have opposite signs and reciprocals. So this becomes -7/3. Now there's one case where that's not true. They're not opposite reciprocals. Here's the case where they're not opposite reciprocals. A vertical line and a horizontal line, okay? So a vertical line and a horizontal line, they are not opposite reciprocals. Every other line that are perpendicular have to have slopes that are opposite reciprocals, okay? But that's the one exception to this, all right? And most of the lines we're talking about are not, they're not vertical or horizontal, all right? Okay, and then we can never, I'm gonna say this, we can never get this directly. Like there's no way we can get this. We always have to get the normal line from knowing the tangent slope. We do have a way to get this, right? It's a limit, okay? So we have to get this before we could ever get this one. We can never get this one by itself is my point. All right. So here we go. I'm going to change this a little bit, okay? We're going to write the equation for the normal to the curve, and I also want to write the equation of the tangent line to the curve, okay? So let's find the tangent slope first, all right? So I want to find this at x equals 1. I want to use a right difference quotient, means that's where I want to find it, so I need a second point. So to get that second point, I'm going to add h to this one, okay? So the limit as h approaches 0 of f of 1 plus h minus f of 1 over 1 plus h minus 1, right? Or just, that's just going to be h, right? So this would be equal to the limit as h approaches 0 of, and okay, so here's an example of, I would encourage you to start using these brackets, okay? So use brackets to show what you're plugging, like to separate the two functions that you're plugging it into, okay? So this one is gonna have a bracket and then minus, and then this one's gonna have a bracket. So this is 4 minus, and we're gonna square our input is 1 plus h. So 4 minus 1 plus h squared, close the bracket. That's showing putting 1 plus h into the function. And then minus, let's show putting 1 into the function. So that'd be 4 minus 1 squared over h. Now we need to square this, right? So this becomes the limit as h approaches 0 of 4 minus, and whatever that square is, right? So it's 1 plus h. I'm going to make it a square. 1 plus h going across, and 1 plus h going down. So that'd be 1, that'd be h, that'd be h, and that'd be h squared. So this is 4 minus, okay, and h squared plus 2h plus 1. If I wrote it like this, I'm dead wrong. I'm dead wrong. Why? Why? It's because I need to subtract what the 1 plus h squared is. I'm not subtracting what 1 plus h squared. I'm only subtracting this h squared. So I have to use parentheses. And then close the bracket. And then minus. And then 4 minus 1 squared. Well, that'd be 4 minus 1, which would be 3 over h. Okay, so this becomes the limit as h approaches 0 of, and this would be 4 minus h squared minus 2h minus 1 minus that 3, right? All over h. So this is equal to the limit as h approaches 0 of, we have 4 minus 1, which is 3, minus the 3, that's 0, right? So this becomes negative h squared minus 2h over h. That you could look at this as being a common, we're adding and subtracting these and over a common denominator of h. So you could separate this and divide each of these by h. That'd be fine. Or I'm going to factor it out. So the limit as h approaches 0 of h times, and this becomes negative h minus 2 all over h. And now, right, the h's cancel. You're left with the limit as h approaches 0 of negative h minus 2. Now, can I plug h in, 0 in for h? Yeah. And what do you get? You get negative 2. All right. So what does this tell me? That's my m tangent, right? My tangent slope at x equals 1 is negative 2. So what's my slope that's normal to it? Well, they have to be opposite, right? So this one's negative, so we know this one's going to have to be positive. And now I'm going to write positive right now, but when we use it, we're not going to write positive, okay? This is 2, but 2 really means 2 over 1, which means over here, this becomes positive 1/2. All right, we also need a point, right? So the point we need is f of 1. So f of 1 would be 4 minus 1 squared, and then that would be 3. So our point of tangency is 1, 3. This is the point of tangency. I'm going to slide this up a little bit. Okay, so here's our tangent line equation, and then our normal line. Okay, tangent line would be y equals negative 2 times x minus 1 plus 3. Our normal line would be y is equal to positive 1/2 times x minus 1 plus 3. Okay, I know I didn't ask for the tangent line, but on the homework I'm going to ask for the tangent slope, the tangent line, and the normal line, okay? And then I've asked you, I'm not going to have you graph it by hand, but I really want you to try, because we got to learn how to use the graphing calculators pretty well. I'm going to have us graph these and show that they do indeed. We can tell if we got it right or not, okay? So both these should be touching at x equals 1, all right? And these should be perpendicular to each other. All right, so I'm gonna go to the graphing calculator and I'm gonna show you that. Okay, so what I want to do next is I want to press y equals. I'm going to clear out what I had in there. And I want to type in the function. So this is 4 minus x squared. So 4 minus x squared. Okay. And then I also want to type in both a tangent line. So negative 2 times and then x minus 1. And then plus 3. And then for the normal line, The normal line is 1/2, so I'm going to use my fraction bar. So 1/2, and then start a parenthesis, and then x minus 1. Close the parenthesis, and then plus 3. Okay, so I'm going to go zoom, and I'm going to go zoom. Let's go zoom standard and see what that looks like. Okay, so here's this, right? Here's our equation of our function. And then this, you see how that's a tangent line right there? It's touching right there at 1, 1, 2, 3, right? 1, 3. Isn't that what we said about the point of tangency? Okay, now here's the problem. Mr. Mitchell, those don't look perpendicular, right? That doesn't look like a right angle. And it's because of the scaling on the graph. So if you look how much longer. Okay, this is 1 unit and this is 1 unit. And the problem is it's been distorted, all right? So right here, it's because this isn't a square window, it's actually rectangular. So this is 10 and this is also 10, but because this is a shorter length, the distance of 1 unit is much shorter than the horizontal one. And that's causing this to not look like it, okay? So I'm going to show you there's a way to fix it, okay? So you go over here to zoom, and it'll make the scaling and on the x and the y axis the same length. And we go down here to z square, so number 5. You don't want to select that. So z square, and there we go, okay? And then you could even zoom in a little bit, and you still see the point of tangency, 1, 3, right there. But now you can tell better that these are perpendicular. You could even go zoom and then zoom box, and you could zoom in on just this top feature. Like there's a lot of extra stuff that we really don't need to see right now. So like press enter there, and then go down like just that, right? And we could press enter and it zooms in on that. And then from here we could do zoom square again. And that looks a little bit better. And you can even see the tangency point a little bit better right there, right? You can see how it's coming in, just touching at that one point right there. Okay, so I'm going to zoom out a little bit. Okay, so then that we have that. All right. So I did some, I want you to do this just because I'd like you to see, and you can tell, did I write my equations right? Because they should look perpendicular to each other. Okay. If you go over here to y equals, I would have them 3 different colors. So you just need to use the arrow keys to get over on top of those. And then you can change colors. You just press enter, and then you could change to whatever color you want. Okay. All right, guys, that's it. This is a big lesson. This is an important lesson, and I know it took a while, but hang in there. All right, hang in there. Okay.